Okay, Trig. Section 6.3 today, law of cosines. We're going to get through this. I'm only going to do 3 examples. Example 1, example 2. I'm going to skip example 3. If I was in class with you, I'd probably do it, but we'll skip it for now, and then we'll go to example 4. So this is solving triangles using the law of cosines. Geometry, this is going to look real familiar to you. Everybody else except Jack and Aubrey, this is going to look decently familiar to you because you should have done it last year. So Jack and Aubrey, you're the newbies. You won't probably maybe have seen this before, but it's pretty easy to catch on, okay? So the law of cosines, just as a review. Let's maybe backtrack a little bit, okay? We have right triangles. And if we have a right triangle, we have options. We can use the Pythagorean theorem, so a squared plus b squared equals c squared, or we can use SOHCAHTOA. Okay, if we have a non-right triangle, they call it an OBLIQUE, an oblique triangle. We have 2 options. We can use the law of sines, which again was sine of A over A equals sine of B over B, something of that nature, right? Or we have the law of cosines, which is what we're learning now. Okay. And the law of cosines is pretty straightforward. The law of cosines says this, okay? It is c squared equals a squared plus b squared. Kind of like the Pythagorean theorem, right? But then it has minus 2ab cosine of capital C, okay? So this capital C right here is an angle. And then we have lowercase c, lowercase a, lowercase b. All 3 of these are going to be sides. Okay, so how do you know when to use the law of sines versus the law of cosines? The law of cosines, we have 3 sides and 1 angle involved in our formula. Versus the law of sines, we have an angle, so that's 2 angles. And we have a side and a side, that's 2 sides. Okay, so how do you know which one to use? You just use whichever one you have the information for. So if I have 2 angles and 2 sides, again, one of them I'm going to be solving for. So I might be solving for an angle. But if the 4 parts involve 2 angles and 2 sides, I'm going to use the law of sines. If my 4 parts involve 3 sides and 1 angle, I'm going to use the law of cosines. Okay, but this is what we have to use for non-right triangles. Now, the law of cosines, they go ahead and they write it in 3 separate ways. But I just feel like that's more to like think about and more to memorize, okay? Those 3 equations are exactly the same. It's just depending on what you're given, okay? So the thing, I don't memorize all 3 of them. I mean, I kind of have them all 3 memorized, I guess. But I only remember this one because it helps me think about it as c squared equals a squared plus b squared. I just remember that no matter what, the angle that I'm talking about and the side opposite him have to go on opposite sides of the equation. So like in this diagram right here, this is my angle. This has to be capital C. This would then be lowercase c, right? So in the equation, it would go like little c here, capital C, 52 here. So I have cosine of that number. And then I fill in 35 and 22 here. So 22 squared plus 35 squared, it doesn't matter which one goes, minus, this part is the 2ab. 2 times, I don't care, 22 times 35. Okay, so my 2 sides that I'm given go here and here. The angle that I'm given goes here, and the side opposite him goes here. Okay, and that's all I have to do, is I just have to make sure that those are in the right place. So it doesn't really matter that you have like all of that stuff going on. You just have to like make sure that the angle and the side are opposite each other. Okay. All right, I'm going to go ahead and keep finishing this because we have the equation all written out. So C equals, we've got to do all this stuff. All right, now you have to be very careful when you go to type this into your calculator because this all is 1 unit together, okay? 22 squared, 35 squared, whatever, but this is all 1 unit together, okay? So if you want to do this in pieces, you sure can. I'm going to do it in pieces because all I have is my stupid phone calculator. So, let's see how this is going to work. All right, 22 squared is 484 plus 35 squared is 1225 minus, okay, I have to do this backwards, so I have to do cosine of 52 first. And then I'm going to take it times the other guys. So times 35, and then I'm going to do some stuff in my head. I'm going to take it times 44, because that's what 2 and 22 would be. All right, and this is minus 948.12. Okay, oh shoot, I forgot. This is c squared, by the way. Fix that. C squared, okay? So I'm going to add that to 484. No, wait a second. 44 plus 1225 minus the 948.12. And I get like 760.88. That's what c squared is. So I'm going to take the square root of that number. So c, this guy right here, is equal to 27.6. They say round to 1 decimal place. So 27.6. You have to take the square root in order to get c just by itself. Okay, again, most of you guys' calculators, you should just be able to type this whole thing in at one shot. Okay, and get that value. I cannot, because I am using my phone and I don't trust it. Okay, all right. They say, I didn't even read the problem though, solve the triangle. So I'm going to go back to what they're named now that I have him solved for. And I have capital A, capital B, capital C, lowercase a, lowercase b, lowercase c. And I'm just going to write in what I had to begin with. What I had to begin with was 52. I had 35, and I had 22. Now, again, we just solved for A, so I'll write him in here in a second. But before we write him in, I'm just going to show you. This right here is how I know that I cannot use the law of sines, right? Sine of A over A equals sine B over B. I cannot use that because I don't have like one grouping, right? Until I do the law of cosines, and I have 27.6 is what I have found for little a, which we called little c over here. But that's what I have here. And now I can do my law of sines, because I can use this as one grouping. And I can solve for like b here, okay? So I've got sine of 52 over 27.6 equals sine of b over 22, let's say, right? Sine of that over that. Okay, so this guy over this guy equals this guy over this guy, okay? All right, and I'm going to cross multiply and divide. So we cross multiply these guys, because we're solving for b here, and we're going to divide by 27.6, okay? I'm going to do that real quick. Sine of 52 times 22, and I get divided by 27.6. And you're going to get a really weird answer. You're going to get 0.628. I'll go 3 decimal places. Like, that can't be right because we're solving for b. Well, that is almost right because that is what sine of b is. So keep that in mind, sine of b. And then how do we get b by itself? We do the inverse sine. Inverse sine. So I'm going to take inverse sine of that guy, and I get b is 38 point, whoa, we're upside down now, 38.9 degrees, okay? Then the last thing I need to do is, you can do that law of sines again to find c, but why do that when you can just add these up to 180, right? So I'm going to add 52, and I'm going to subtract that from 180, and I get like 89.1-ish, okay? Last thing, do me a favor before you move on to the next problem, and check and make sure. This guy is my smallest angle. He should be opposite my smallest side. Biggest angle, biggest side. We're good to go, okay? All right, let's do another law of sines, or law of cosines really quick, okay? What do you do when you have 3 angles and no sides? Or excuse me, 3 sides and no angles. Let's see what we've got going on here. So we don't know capital A, we don't know capital B, we don't know capital C, we don't know any of them, right? But we know little a and little b and little c, all of those guys, okay? Little a is 24.6, little b is 16.2, little c is 33.5, okay? All right, I'm going to write out the formula. So c squared equals a squared plus b squared, minus 2ab cosine of c. Okay, now again, you can move your stuff around however you want. If you want to, if it makes sense to you, we could solve for capital C here first, right? So I'm going to pop 33.5 in here, squared, equals 24.6 squared, plus, just keep in mind, know that you can swap these around if you want to. If you wanted to solve for capital A first, it doesn't matter. Just if you were solving for capital A, this guy would have to go in this spot, right? And then your other two sides go in a different spot, whatever. And then cosine of capital C. Okay, now this is a little bit different because you're solving for this angle over here, all right? Now, I am going to do this. 33.5 is something. I'll write this all out for you, and then you guys can decide what shortcuts you want to take. This is 1122.25 equals 24.6 squared is 605.16, 16.2. Whoop. This is 262.44, and then minus 2 times 24.6 times 16.2. This is 797.04 cosine of C. All right. You geometry kids, you know exactly what I'm going to say. I have people all the time that try to screw this up because they add this together with this and then subtract that. Okay, you can certainly add these two together. That's no big deal, but this is attached to the cosine, so you cannot put those two things together, or those three things together. You can put these two together, but not the other ones, okay? So these two together would be like, I don't know, 0.60768. Let me check that. 867.60. Yes, minus 797.04 cosine of C. 1122.25. Okay, I'm going to subtract the 867.6. We're almost done. I know this problem seems like a super really long one. Okay. 1122.25 minus the 867.6. And that is 254.65 equals negative 797.04 cosine of C. Okay, now I'm going to divide by negative 797.04. Divide by 797.04. Negative. I'm going to write out all my steps. You don't necessarily have to write out all your steps. And I get cosine of C equals negative 0.319-ish. Okay? And now to get C, I'm going to do the inverse cosine. Well, hey! And I get capital C is 108.6 degrees. Okay? 108.6 degrees. That seems like really big, right? But he is my longest side. And that seems appropriate. 108.6 degrees. Come here. Come here. Are you ready to be my assistant again? Come here. What you got? Well, hi. You found a toy. Come here. Yeah, bring it here. Bring it here. Oh, dear. There. Okay, now, wonderful part. We've got to do a little bit more work, but we can use the law of sines again. Okay, you should only have to do the law of cosines one time in each problem, okay? So I can do sine of 108.6 over 33.5 equals, I'm going to go sine of, let's just do B next, over 16.2. Again, we're going to cross multiply, and we're going to divide. Okay, and that equals sine of B. Here's your toy. Here's your toy. Okay, well, all right, I'll get my calculator rolling here. Sine of 108.6. Okay, times 16.2 divided by 33.5. And I got like 0.458. If you're writing all your steps down, you don't necessarily have to. I don't care. Inverse sine of that, capital B, is 27.3 degrees. Okay, last thing, my favorite. Add these together and subtract from 180. And I get 44.1 degrees to solve that. Okay, so a little bit of work, but that's solving for an angle. Now, I didn't show you how to cheat yet. I haven't. Well, yeah. Anyway, here's how you cheat. They give you the formula up here. Isn't that so nice? If you're solving for an angle, here is this. This is just this rewritten. So it's already like solved for you, right? Like with everything moved over. Got it? Okay. So yeah, if you want to use this alternate form here first instead, you totally can. Okay. And that may make it a little bit faster rather than having to unwind. Whatever. Okay. All right. Last thing, Heron's formula. I don't know if you remember doing area the other day with a triangle where you're given stuff that's not very nice, but it was like 1/2 AB sine of capital C. And it was like, if you're given a triangle and you have like this angle is 70 degrees and you know that this is 12 and this is 16, right? Let's say feet and feet. All you do is plug this in for A, plug this in for B, plug that in for capital C, and you will find the area, right? The two sides that you have are right next to the angle. Well, how do you find area when you're given 3 sides and no angle, right? Like here we have capital, I'm using this diagram right here. They have, let's say this is capital A, capital B, capital C. Little a is 12.2, little b is 16, little c is 9.8. Like, how do I find the area of that? Okay, and it is using this formula right here. Well, go on down. You can go on. There. I'm almost done. I have one left. I know. We learn patience really fast. All right, so the first thing, yeah. Okay, first thing we have to do is this little part right here. We have to figure out what like S is, which is something that we use up top here, okay? So S is 1/2 of all of them added together. So I take 12.2 plus 16 plus 9.8, and I take half of that, and that's what S is, okay? This process is actually pretty fast. Like, it looks like a big long formula, but it's not too bad. Plus 16 plus 9.8. And we get 38 here, and half of that is 19, I believe. Yep, 19. Okay, so S is 19. So I'm going to plug 19 in here, 19 here, 19 here, 19 here. Okay, so basically the area is going to be the square root of, we start with S, which is 19, times, and I take 19 minus the first number, 12.2. I take 19 minus the second number, which is 16, and I take 19 minus the third number, which is 9.8, okay? And I'm just going to do that for each one of these. 19 minus 12.2 is 6, I'll use a different color. This is 6.8, this is 3, 19 minus 9.8, I should know that, is 9.2, and then we're just multiplying all 4 of those numbers together. So 19 times 6.8 times 3 times 9.2, and then I take the square up. That is the square root of like 3565.92, if you're wondering, and I get the square root as 59.7, and that is in centimeters squared. So that's another way. It's called Heron's formula because whoever came up with this had the last name of Heron, I guess, or something. And that is how you find the area of a triangle with 3 sides instead of 2 sides and an angle like we did over here. Okay? All right. That was a really long video. I'm sorry. But homework is these guys right here. There are 7 problems. Okay? So get to working on those, and we'll go over questions tomorrow.